Why the lady white arrow? Why white arrow? Yes. All of them. Whatever was I1 divided by okay. So that is the representation of I divided by B. Today.
So very good afternoon. So I welcome you all for the section second. Actually, we are done with the case lecture, the chapter number 5 and the 6. Still, I will revise the some part of the chapter 5. So we'll understand the next part in the chapter remaining chapter 7 and 8. Okay. So chapter 5, section 2 basically deals with the exactly PIC microcontroller. That is called the peripheral interface controller. And in that we have this series peak 18 16 18 7 77A. Okay, that is 18F77A or the 16F77A. This microcontroller peak controller where it is using. Okay, so basically in the chapter 5 we have the simple basic features of the peak controller. What is that, how it differs, then its introduction, then architecture diagram, and how what are the instruction set. So let me talk here. This is a microcontroller belongs to the family of the RISC. And the chapter first chapter itself, we have seen the difference between the RISC and the CISC. So what is meaning of CISC type of controllers, and what is meant by RISC type of controllers? Okay. So CISC, we have said that what is the meaning is complex instruction set computing or computers, and here is what a reduced instruction set computers. Okay, so meaning is that this controller peak, that is 16 or 18 F77A, belong to the category of RISC. RISC means reduced instruction set computers. So only 35 instructions are used in this kind of microcontroller, and the programming is a little bit complex because we have to use the that word and the file registers every time to do the programs for the peak controller. Okay, so let's go with these are the outlines. As I said that we'll see what is the next part. If we talk about the nomenclature, the title chapter indicates peak 16F8778 microcontroller core features. This is the name of the chapter. So peak as defined, it's a peripheral interface controller. Okay, and it's 16F, it is the name of that controller, and F indicates that what is the ROM memory is that it is made with the flash. Okay, flash ROM memory is there. That is meaning of F is there. Sometimes we use the 16C also. C indicates the CMOS based logic families. Okay, and microcontroller, everybody knows that it is simple, small, tiny semiconductor chip based on the clock driven. It starts operation, the processing the input and provide the desired output. Core indicates that it's exactly hardware. Okay, what is the hardware and what is inside that? That is meaning of core. And the features will understand what exactly what are the benefits if you compare the 8051 and the 16F877A. It will differ. What are the differences will be there? That will be additional features, or you can say merits of that particular peak controller. Okay, so this is a nomenclature of our chapter. Let's go with the first point, introduction. So in that I define some features in that. Okay, so peak is called as a high performance RISC machine. So RISC is nothing but reduced instruction set computing. Means it has only 35 single word instruction. So your word indicates exactly 16 bit. Okay, so we have the bit, then byte, and then word. Okay, so when you talk about 16-bit forms the word. Okay, it has all single cycle instruction except for program. That is the branch which requires the 2 cycles for the execution. Okay, in case of this, then it operates with the operating frequency as we use the crystal frequency in case of 8051 12 megahertz, but we can connect from 0 to 20 megahertz clock input signal to the this peak controller 16F877A. So we have this specifically controller in our syllabus. Okay, then if we talk about 20 megahertz, it provides the instruction cycle timing 200 nanosecond. And if you compare with the controller, we have very large one timing cycle, instruction cycle in case of 8051, because we have the 12 megahertz crystal, 12 divided by 12, we are getting the 921 kilohertz frequency, and based on that, nearly 1 microsecond time is there. We compare 1 microsecond time and 200 nanosecond. This is very small. Means the speed of operation of this peak controllers is faster one as compared to the 8051. Okay. Then we have the flash ROM memory, that is as mentioned here, flash program ROM. So F indicates flash. It has the 8 kilobyte of that. Whereas in the 8051 we have the 4K. So all these MCQ type questions will ask based on the each feature. So please try to understand features and the meaning of that. So it has the ROM of 8 kilobyte, and each ROM address which I mentioned size is going to be 14 words. So it indicates 8K by 14. So it has 8 kilobyte ROM, and the size of each memory byte there word is a 16 word. Okay. Then it has up to 368 byte. If you talk about 256 byte was in the 8051, but in case of peak controller, we have the 368 byte of the data memory, that is called as a RAM memory in that. Okay. Along with this, it has a 256 byte of EEPROM data memory. So it has the two types of data memory. One is called as a permanent, other is called as a EEPROM base. So this can be erasable. And it comes, this control IC comes with the pin out of 20 pin to the 40 pin. So specifically, if you talk 16F877A, it has the 40 pins that can be used. Okay. So which IC it is used? 16C and 16F families. So C indicates it's a CMOS based logic family. Means that IC is designed or configured with the CMOS based logic family. But in case of this, it is a flash memory type is used. So these are the features. Let's go to the next. And these are the overall features, but we talk specifically what is inside that controller that will define its core features. What are the peripheral? Peripheral means what? What are the on-chip devices are there in that IC? If you look out the architecture diagram, you will understand that part also. So it has the timer 0, timer 1, timer 2. So in case of 8051, we have the only two timers, timer 0, timer 1, which is size of 8 bits only, and it operates in the various modes. Okay. But in case of peak, we have the timer 0, timer 1, timer 2. The timer 0 is of 8 bit that can be act as a timer as well as the counter. And not only this like timer counter, it can be used for the 8 bit prescaler. Means what is the time constant count value is there? I can multiply with the 2's multiple, 3's multiple, 4's multiple to that value. Means it's called the prescaler. Timer on size is 16 bit that act as a both timer counter, and last timer 2 is the 8 bit timer counter. Okay, so in this case, if it differ, it has a post as well as the prescaler. Pre means initially multiply the count value and then start incrementing. It reaches to the maximum, and then roll off occurs and we're getting the flag, means interrupt occurs. And the post means first increment and then multiply. That is meaning of post scalar. Okay, if you understand that meaning of I plus plus and plus plus I, that is the instruction used in the loops, in the for loops or the while loops. Okay, I plus plus means what? First increment and then go for that. Post increment is there, and meaning is that plus plus I pre increment. That is the pre, and this is called as a post. That is meaning of that. If I define I equal to 0 and I return I less than equal to 10. Okay, meaning is that it will start with the I equal to 0, then it will increment 1. Okay, then I will be first 0 and then it will be incrementing, and then I'm getting the value I equal to 1. But in case of this plus plus I, initially it will increment, that will be I equal to 1. That is meaning of post and the pre. Okay, so that is it has the post and prescaler values. Not this timer, not only it has a timer, but it acts as a counter, and it also provides the capture compare modes. So 16-bit maximum resolution 12.5 nanosecond, and the compare of 16-bit with the resolution 200 nanosecond. Now, what is the meaning of capture compare? We are going to see. Still, I'll tell here what is exactly meaning. When we talk, the time slap is going on, the clock pulses if it is having like this. Okay, and I want to capture certain timing interval from that. So we have the capture registers in the timer. So in the capture registers, control register, so control registers are there. In that capture control register, if I have stored the certain value, for example, I can say it is 100 nanosecond. So when the clock signal going from that signal and when exactly coming at the 100 nanosecond, it captures the that value. Okay, and that is meaning of capture registers. And the compare meanings what? It also has that compare registers. So what is timing values going on? The timer count values. So it going to compare with the values stored in the previously. Okay. So meaning is that it can compare the value of that. Okay. So this compare a register. Is for example, if I stored the value of 10, then timer clock will going from 1, 2, 3, 4. When it is coming in the 10 value, the output of this will be raised to the 1. That is meaning of compare. Okay. So this is additional features which is not there in the 8051. The PIC will provide that. Then it has PWM max resolution of 10 bit. So pulse width modulation, that thing is used for to control the speed of operation of the DC motor. Okay, or sometimes in the servo motors also. What are the conveyors are where connecting to control the speed of that? The PWM can be used. Now, what is meaning of exactly PWM? If we use simple pulse width modulation, the width of the pulse varies as per the input data. Okay, so I'm defining the duty cycle is equal to T on by T. T is nothing but T on plus T off. So this is for the 50% duty cycle. If I want this 60 or 70% duty cycle, the T on going to be increases. So I'm getting the cycle of large T on period and the small T off period. Means the maximum current is on for the this much time interval. So the speed of the motor going to be on for maximum time. That is application can be used the PWM in the control of the speed of the DC motor. Similar way, in the 805 how the TX and RX pin for the serial communication. In case of peak, we have the various on-chip serial model communication models that is called as a SSP, serial synchronous serial port. Then SPI, serial peripheral interface model is there. I2C inter-integrated circuit bus. Along with this, it has the SCI communication also. Okay, so all these chips are available to perform either it is synchronous or asynchronous communication between the our peak controller along with the other outside the peripherals. Why this is required? These things required when we have the two or more number of output devices to communicate with the controller. Okay, so using this communication protocol model, I can interface and I can perform the communication between that. Then it has the parallel ports and all this thing, and it has various reset circuits also. Out of that, it has a brownout reset. When the power fluctuation occurs, we need to use this brownout reset circuit. And automatically, when the power fluctuation going beyond the limit, it automatically resets the peak controller. So as I mentioned here, it has analog features in that you have the brownout reset. Along with it has the ADC and the DAC. On-chip ADC of the 10-bit and the on-chip ADC of DAC. This is the simple pinout diagram of the 40 pin. Okay, the tool in the package. This is the code in the package that is in the 40 pins IC. Okay, so this is actually a architecture diagram of the PIC controller or peripheral interface controller 16F at 77A. Actually, it's not. I'll go with my PDF file. So understand that. So as we know that when we talk about any controller, we require its main unit part is called as a CPU. So that will form with the ALU unit and the registers. What is there in that? Okay, so that form with the arithmetic and logical unit. So what are the operations are there that will be performed under this? along with the work register. It has the additional part in that. Okay, that forms of that. What is the size of it? It is 8 bit. Okay, but the size of the data bus, it is going to be 13 bit. Okay, sorry, program counter size is 13 bit, and it has a ALU size of data bus of 8 bit only. Okay. Then, as I said, that it has the flash memory of the 8 kilobyte, and the internal two RAMs are there. One is called the data RAM of 368 byte, another is a 256 byte of EEPROM IC is there. Okay. And if we talk about the flash memory, ROM memory, why it is used, when we write the code, what is the code we're writing? The hex file, binary file is going to be stored in that ROM memory. Then it has the 13-bit program counter. The function is that program counter always point the next address of the instruction. In case of this PIC, it supports for the three-stage pipelining execution. That is called as the fetch, decode, and the execute. It will happen in the one cycle. Okay. So one instruction will be fetched at the same time, other will be decoded, and the third will be executed. That is meaning of pipelining execution. Then it has instruction registers. So when you write an instruction like this, move WF, meaning is that the contents will be shifting from work register to the file registers. Okay, but how this understand for the move instruction? It has particular opcode value, and that opcode value is stored in the ROM of that particular memory. And always when put opcode of move, it will compare in the by using flash ROM opcode stored in the ROM, and that is done by the instruction register. That is the meaning of to what action need to be taken by the controller will be decided by the instruction register. Okay. Then we have the direct address of this means what are the instructions are there. We can configure categories in the three categories. That is called the direct addressing, indirect addressing, and the immediate addressing. Then if you go with the bottom side, as I discussed, it has additional features like that. It has the some brownout various resets. That is power on reset, power on a reset is there, watchdog timer reset is there, brownout reset is there, and low voltage programming means it can operate with the 5 volt, and it can operate with also 3.3 volt. Okay. These are the additional features in that. Along with these, it has, as I said, the serial communication protocols. That is I2C, SPI, and SSP ports are available, and the three timers are there. That is timer 0 8 bit. We have seen the features also. Timer 0 is of size 8 bit, along with the prescaler value of 8 bit is there. Timer 1 size is 16 bit, and it has a prescaler value of 8 bit only. In case of timer 2, it is 8 bit only, but it supports for the both pre as well as the post scalar values. And it has again 10 bit ADC, means 40 pins out of that 33 pins are there for the ports only. Okay, but this is actually I'm looking for at 77A. I'll go with the at 77A. So it has the additional ports, that is port A. 5 ports are there: port A, port B, port C, port D, and port E. If we talk about port A, it is only 5 bit, and then B, C, D, it is a 8 bit. So 5 plus 8, 3, 24, 24 plus 5, 29 plus 3. These are the 6 actually, yeah? 6. 30, 30, and 3. Port E will be 3 bits. That is the 33 IO pins are available in case of PIC controller. Okay. And all these pins are going to be multifunctional pins are there. Okay. Okay, so these features discussed in that is the peripheral features that will display in the arcade diagram itself. So what it has inside, that is defined here. Okay. So without wasting of this time, so these features and all these things we have seen in chapter 5. Uh, let's go with next slide. So this thing, as I discussed, because of the some revision we need it here. So we need to look out what are the peripheral features we are look in that chapter 5. We need in the chapter number 7. So in detail discussion of this will be we are taking in the chapter number 7. That is called as the peripheral features and the programming. Okay. So in that, what we have seen just timers. If you talk with here, the diagram, it has a timer 0, timer 1, timer 2. So how this timer internally operates and how it supports for 8 bit means maximum count can be taken 2 raised to 8 will be 255 means 0 to the FF, the hexadecimal. So when that timer 0 and time internally registers TH0 and TL0 reaches to the maximum count, roll off occurs and the interrupt will be generated. That we have to see in the chapter number 7 specifically. So all these features, timer 0, timer 1, then CCP, capture compare mode, watchdog timer, all these things. And the last chapter 8, we have the serial communication protocols, what we discuss here, SPI, I2C, USB, USART. Okay, so chapter 7 deals with the timers operation, ADC, DAC, watchdog timer. These things will be there in that. So outlines of the chapter is going to be timers, that is timer 0, timer 1, timer 2. Then we have the capture compare modes along with this PWM, how it is used, these models, then internal ADC, DSC, and last as a watchdog timer. So out of this, we'll focus on the first timer. So what is timer? All these things we'll see. So as we know that we have discussed in the Edger file also, what is timer? So timer is a device which provides the various time delays. Okay, and how it provides based on the size of the timer. So we can say timer has the size, timer 0 has the size 8 bit, along with the 8-bit scalar values are there. So maximum 2 raised to 56, 1 to 56 counter value, integer value can be multiplied to the timer count value. Okay. Then timer 1 is of 16 bit, the timer 2 is going to be 8 bit. So as we know that timer is going to be multifunctional, can be act as a counter also, and that can be used for the capture and compare mode of the operation. Okay. So this timer can be operated based on the what the clock pulse is given. Either I'm giving from the internal clock oscillator, or I can connect from the external crystal oscillator. That depends upon the it's an internal diagram of the peak controller. We can see that how it operates. Okay, so let's just understand here what is timer. Timer is a device which provides the different time delays based on the size of the timer. And additional feature is that it has time scale values. Just I'll write here what is meaning of that prescaler and all this. So in case of 8051, we have seen that we have the two timers, timer 1 and the timer 0. So if you talk about T mode operation, timer mode operation, we have seen that this timer can be act as a either timer or the counter. Okay, so it has the modes operation. Okay, M0, M1, and here is a C bar T, and here a gate. Same way for timer 0 also, timer 1 also, it has that M0, M1, C bar, oblique T bar, act as a counter timer, and the gate. Okay, so this is a 8-bit timer only. It operates in the modes. So as it has the 2 bits are there, M0, M1, it has the 4 modes of operation, mode 0, mode 1, mode 2, mode 3. That is for 8051. Similar way, in the peak controller 16877A, we have the timer 0, 8-bit, timer 1, 16-bit, and the timer 2 of 8-bit, along with the values pre-scalar and the post-scalar. Now, what is meaning of that portion? Please clear understand. When we design the timer 0 for 8-bit operation, okay, so maximum count will be 2 raised to 8 will be 256. Meaning is that 0 to H to maximum FF H. This count can be taken by provided by the timer 0 in case of peak controller. That is a 8-bit size. That's why. Okay, means when the time delays are uploading in the TH and the TL file, it starts from the this value reaches to the maximum FF. Once this count value reaches to FF, roll off occurs. Once roll off occurs, what happens? The TF0 flag is going to be raised. In case of TF0 is not there, but timer 0 flag is going to be raised and the interrupt occurs. So this is simple operation of the timer. Let's understand that. We'll go with the timer 0 operation. See, this is timer 0 operation. Applying the either internal crystal oscillator frequency clock frequencies or external clock frequencies. And that is counted here and that is given to the prescaler. Means what is the count value is there? Either I'm multiplying with the 4, 6, 8, 16 multipliers. Okay, that is meaning of prescaler, just multiplying the integer value with that clock pulses. Okay, and this clock pulses I'm counting. So by connecting here timer decibel P, once this will be high, the number of pulses passing from the AND gate is counted here, timer count up to maximum FD value. Okay, so once this count value counted by this counter here, once reached to the maximum FF, what happens? Roll off occurs and the overflow means the flag will be raised. Okay, and the interrupt going to be generated for the timer 0. Similar way, if we talk about timer 1, it has a 16-bit size. So maximum count will be 2 raised to 16. That is 4 times FFF. Means in the decimal, 65,536. Just we have seen for the mode 1 operation, it is of 16-bit size in case of 8051. Okay. So there is a table given on what is the minimum and maximum time delay can be provided. So as we discussed, TH0, TL0 is not there, but we have the TMR0 is the register user for to load the count value, that is FF, and that side is going to be 8-bit only. So in case of timer 1, 16-bit is there, that's why TMRL and TMRH. So 8-bit will be loaded in the lower timer value registers and the upper 8-bit MSB loaded in the higher timer registers. Okay, so this for 16-bit. And in case of timer 2, we have the timer 2, only 8-bit can be loaded. And minimum delay 0.2 second, maximum for 8-bit 13.10 millisecond. And in case of timer 1, 104 millisecond. And in case of timer 2, 819 microsecond. You indicates micro unit. So based on this, MCQ is asking, so try to remember this table. What is the size of timer? How many timers are there? And what is the minimum, the maximum time delay can be provided? So this is a timer 0, specifically we are looking for. So these are the features. As I said that it is a 8-bit timer. Maximum count value will be 0 to FF 2 raised to 8. That is 256. It has 8-bit software programmable prescaler. Means we can multiply the 8-bit values like 2, 4, 8, 16 to the count value. And the timer is both, it is a readable as well as writable. So you can write or read the timer. And all this count value can be counted based on the edge select. Means it is an edge triggered clock pulses can be counted. What are the registers used? Option registers is there. Timer 0 to load the count value and intcon, internal connect register is there. Control register is there. So look for the internal block diagram of timer 0 operation. So starting with the mux1, the mux1 meaning is that it has the 0 and 1 inputs. So either I can select the internal clock pulse or other external clock pulse. So this is from the crystal oscillator connected pins TCK. Internal clock pulses can be taken through the XOR gate. If the mux input 1 will be there, it will take the internal clock pulse input. If it is 0, I can take from the external clock pulse input. Okay, so that input is given to the second mux position, and which will decide based on the PSA value. The PSA value is going to be 0. I can take the internal clock pulses multiplication. If the PS equal to 1, I'm taking the watchdog timer clock pulses for the generation of the time delay. That is meaning of PSA 0 equal to 0 and PS equal to 1. Okay, and that pulses is given in here, the number of cycle pulses counted, and that values goes in the timer 0 registers. Once this count value reaches to the maximum value, that time the flag will be raised and the interrupt would be occurred. Okay, so similar way, if we have seen just for the mux 4 input will be 1, that this either from the external the internal clock pulses can be given for the loading the count value in the timer 0 register. But if the mux 4 has the 0 input, it will take the input from output of the prescaler component. So we have the 8-bit prescaler that can be give the count value of 2 multiplied by 2 or 4 or the 6 or 8 like that. That will multiply with an output will be given here. This is for the mux 4. If in case of mux 2, if the input will be 0, the either from internal or external clock pulses is given if the output will be 0. But if for mux 2, the input will be 1, the output of the watchdog timer is taken for the as a clock pulses, and that output is given for the 8-bit prescaler multiplication. Okay, and then based on that, if, as I said that if the input will be 0 for the mux 5, the output of watchdog timer is taken. Otherwise, if the input is 1, the output is given for the watchdog timer T out. Means timer will be out. TO is called as a T out time interval of the watchdog timer. It will reset the control automatically when the T out will be over. So this is a simple basic operation of the timer 0. How it's working also based on that we have seen if the case 1 PS equal to 0 and PS equal to 1. The PS equal to 1 means what? The timer 0 is selected. If PS equal to 1, watchdog timer is going to be selected. And this defines mux 1, mux 2, mux 3, mux 4. Either input will be 0, what to be selected, and if input is 1, what to be selected. Simple mux 1, if mux 1 is input 0, select internal clock source. Here is the diagram. If mux 1 input is 0, you select the internal clock diagram. If mux 2, sorry, mux input is 1, you select the external clock cycle signal. Same way, mux 2, select the timer, watchdog timer, either timer or watchdog timer. If mux 2 is input 0, select the timer. If mux input is will be 1, select the watchdog timer. This is the diagram for that mux 2. If the 0, select the timer operation. If the 1, select the watchdog timer operation. So other will be same. What is input coming based on the 1 or 0 condition? Select lines will be selected and output will be given here. Its second case, if the PS equal to 1, the watchdog timer is selected. Means the timer 0 will be configured as it's a watchdog timer. When it will be PS equal to 1 in that case. And same operation for the mux 1 and mux 2 also. So in this case, mux will be input will be 0. It's a timer 0 operation. If it is 1, watchdog timer operation. Okay, so this is for the internal block diagram of timer 0. Its operation is seen. And then next lecture will go with the timer 1 and timer 2 operation.